The broadcast is now starting. All attendees are in listen-only mode.
Hey, what's going on, everybody? Welcome to our webinar today. I apologize, I'm a couple minutes late. I had a little bit of a technical difficulty this morning. My laptop that has been plugged into the wall and in the docking station just told me it was out of battery and it shut down on me. So I restarted it, and now it looks like we're good to go. So I just wanted to thank everybody for logging on today and for signing up for this webinar. We're really excited to share what we've got with you today. Yes.
I think your presentation just disappeared.
Did it?
No, I'm just messing with you. Anyway.
You would do that. And without further ado, let me introduce my panelists today. We have with us Mr. Jokester himself, Randy Wahlen. Randy with Oldcastle Precast. How are you, Randy?
You know, I'm wonderful. Thank you, Jason.
Excellent. Well, that pleases me. That pleases me. Also with us, the wonderful Heather Christensen from Geneva Pipe and Precast. How are you, Heather?
Hey, Jason, doing well. Thanks for having me.
Absolutely. Thank you for being with us today. And last but not least, also Mr. Michael Blackham, also with Geneva Pipe and Precast. How are you, Mike?
Doing good. Thank you, Jason. Hope it's beautiful weather there as it is here in Boise.
It's not bad down here. I do want to give a special thank you to Mike. He showed me, he got on a webcam call with me the other day, and out of respect for me, he decided to shave and get a haircut. So thank you, Mike. I appreciate that. I still have nightmares about what I saw when you showed me your quarantine look. So again, thank you everybody for joining with us today. This is one I've been waiting for a while, that I've been excited to give this presentation. Not necessarily so much about the content as much as the pajamas that I'll be wearing today. So I'm excited to share that with everybody. I want to just do a quick introduction for those of you who don't know me, and then we'll talk a little bit about the format of this this webinar and how we're going to work it today. My name, of course, is Jason Allen. I am the director of Mountain States Concrete Pipe Association. I have my engineering degree, and I got that from University of Utah, proud University of Utah graduate. Got my bachelor's and master's degree. I've got 18 years of experience in the engineering field. Started out as a surveyor, worked in land development, worked in the public sector as the Morgan County engineer, went into consulting, and now I do marketing engineering for the Mountain States Concrete Pipe Association. For those of you that are not familiar with Mountain States Concrete Pipe Association, we have a few member companies that I want to recognize. I've already introduced you to a couple of our panelists that are representing those companies here today. We have Geneva Pipe and Precast with plants, manufacturing plants in Salt Lake, Orem, and the St. George area, and Oldcastle Infrastructure with manufacturing plants in Ogden, Idaho Falls, and the Boise area. So we want to recognize both of those member companies who manufacture our pipe, and thank them for allowing us to continue to put on these webinars every week. We also want to give a special thanks to our two other member companies that we have, Ash Grove and Wholesome. These are our cement suppliers. They do a lot for our association and make a lot of what we do possible in helping us and giving us guidance and direction so that we could be the very best that we can. So I want to give a special thanks to them. This is, for those of you who have attended these in the past, these are what I call the pajama presentations. And so I am currently sitting in my pajamas giving this presentation. I hope some of you are having that opportunity to sit back in your pajamas on a Friday as well. So the format of this, if you have any questions, there is an opportunity in the webinar that you have a control panel that you can type your questions in. I will be answering those questions at the end of this presentation. And so feel free to just submit your questions throughout the presentation, and we will get to those at the end. I will be recording this presentation, and I will be uploading all these presentations to most likely a YouTube channel. I wanted to put them on our website, but we've had some issues, and so I'm going to be just putting those on a YouTube channel, and I'll send out the link so that if you want to go back and review any of these presentations, you'll be more than welcome to. I had some requests and questions recently if I would be willing to share some of these slides. Absolutely, I'd be happy to. If you have any questions or you want any of the information here, just reach out. I'd be happy to share any information that we go over today or that we've gone over in previous weeks. We will be having additional presentations in the coming weeks, so we'd invite you to keep an eye out for those. I'll be sending out invites on Monday. Next Friday, we will be talking about working with different generations. So that's the millennial presentation that I've given at APWA and City Engineers and a few other places. So hopefully you can all attend that. That's a real fun presentation. I enjoy doing that one. So the purposes of these pajama presentations. One, the hope is that we can build some technical skill and provide you with some continuing education. I will be sending out on Monday a professional development hour certificate for 1 PDH for those of you who need that for your engineering licensing. So we're hoping that we can provide some level of technical skill to you and help you learn a little bit more about pipe or other topics that can help you in your career. The second purpose is that we're hoping that we can provide you with some type of a little break, maybe a little bit of entertainment. We're hoping that you find a little bit of joy and fun in what we have to present to you. And so we're just hoping to kind of break up that day. A lot of you I know are working from home or are working in situations where maybe there's not as many people around as you're used to. And so hopefully this is an opportunity for you to provide a little bit of a break there. And last but not least, and certainly most important in my mind, this gives me an opportunity to once again be the center of attention so that everybody can listen to me and sit as a captive audience, and I can be that center of attention. As I mentioned before, I do give these in my pajamas, so I always share a picture of what pajamas I am wearing this week. And in weeks past, I had my Superman, my Santa Claus, my Batman jammies. This week's pajamas are as follows. My unicorn onesie.
I was going to stop you. I was nervous.
Nope, these are. This is my unicorn onesie. I'm very proud of this.
Oh man, are you sure that's not Aubrey's unicorn onesie?
That is my unicorn onesie. A gift from my sons. They thought it was hilarious. I thought it was. Now I wear it unironically, and they get ashamed now. They bought it for me as a joke, and I wear it unashamedly. If I have to go out and get the newspaper or the mail, you better believe I will wear this out in public just to embarrass my. My children. So that's the goal there. So with that, why don't we do our first poll? I like to do this first poll every week just to check and make sure our polls are working. So I'm going to launch that right now. The poll is: are you currently wearing your pajamas? Feel free to answer that question. We'll give it a few minutes just to make sure that these polls are working. All right. Okie doke. It looks like we've got quite a few of you voted there. I'm going to close that. I'll read you the results here. It looks like we've gone up a little bit every week on the you know it, the yes. This is the fourth time I've asked this question. It looks like it's gone up from 10% to 12% to 15% and now 16%. Most of you know, but you wish you were. Don't I know that? Okay, 27 no because I'm an adult. 27% said no because I'm an adult and I have actual work to do. Well done. And 27% of you said I don't wear pajamas. Ooh, look at you. That maybe was wildly inappropriate for me to share that. So, okay. Thank you very much for sharing that. It looks like our polls are working. I'll be having a few more polls throughout the presentation. Just so that you're aware, this program that we use, GoToWebinar, will track attentiveness. So we will be watching to see who is ranked as the most attentive listener for this presentation, and we will be sending out a gift card to the one who pays attention the most and is most attentive. So keep an eye on that. Make sure you're focusing and paying attention. Okay. Couple of the takeaways that we want to discuss today. First, we're going to talk about the different types of installation. We're going to talk about the basics and best practices for installing reinforced concrete pipe. And we're going to do briefly at the end, not too much, but we are going to have a very basic comparison between pipe materials on installation. But most of this presentation today is going to be about the best practices for reinforced concrete pipe. So We're going to do before we jump into the installation side, I'm going to do just a high level review of some things that we've talked about in previous weeks. Our first week, for those of you that attended, was about all the fundamentals of reinforced concrete pipe, more on the design side. And so today we're going to be talking about a little bit review there, and then we're going to talk about now the installation of that and how we get it from the paper into the ground. So buried pipe must perform two critical functions. This, for those of you who were here in the first week, you'll remember the answers to this. It has to act as a conduit. So it must, if we're talking storm drain, we've got to be able to get that water from point A to point B. So it has to act as a conduit. And the second thing that buried pipe or a buried pipe system needs to do is it needs to be a structure. It has to be able to carry that load so that we could put things on top of it, whether it's a roadway, whether it is any even just landscaping or fill over the top, whatever it is, it's got to be able to hold something on top of it. So that's what we have to do, conduit and structure. Keep that in mind. So as we focus today, we're going to be talking about concrete pipe, which we refer to as a rigid pipe material. Okay, other rigid pipe materials would be like clay pipe, which we see a lot of that, or we used to see a lot of that years ago. In fact, I remember replacing a pipe in a sewer line in Ogden City that was almost 100, I believe it was 96 years old. It was a clay line pipe, and we replaced it to upsize it to a larger diameter pipe, but it was still in great shape. These rigid pipes will last a long time. But concrete pipe or rigid pipes, these are structures that are bedded with soil. So it is an actual structure there. The pipe itself is going to be responsible for anywhere, depending on the classes of pipe that we're specifying, it's going to be responsible for between 70 and 90% of the total system strength of that pipe system. So the pipe itself is very strong and very durable there. Okay, the other crowning characteristic of these rigid pipes, and especially reinforced concrete pipe, is the long service life that these have. If you were here a few weeks ago, we talked about a project that was done in the City Creek project that was over 100 years old. Portions of that line still in service today and in pretty good shape. So these things will last a very, very long time. This is a picture that is of a pipe that was installed in Mohawk, New York in 1842, and it was removed in 1986. This was actually a non-reinforced concrete pipe. We don't even sell non-reinforced concrete pipe in our market here in Utah and Idaho. We are all reinforced concrete pipe, but this was a non-reinforced piece of concrete pipe. This pipe was 144 years old when it was removed, and it was still structurally sound. Now, when I look at this pipe and I think about it, and I think, why did this pipe last so long? Why was it able to last 144 years? And one reason is because the material is one reason. Concrete pipe, we know that concrete gets, as it cures, and it gets stronger over time. But there's other pipes that, depending on the material, that seem to fail a little bit more prematurely than 144 years. And so you have to ask yourself, why would this pipe last so long, and why are other pipes failing? And what it comes down to is installation. Okay, this pipe that lasted 144 years, still structurally sound, this pipe was installed very well. Okay, there was good installation. They used best practices back in the mid 1800s, and they took great care to install this pipe correctly. And so a properly installed concrete pipe will last a very, very long time. And so that's what I'm hoping we can get across today, and what we can learn. We can learn some best practices together, and hopefully you can pick up some things that will help you, whether you're designing or inspecting or installing this pipe. Okay, so before we move on, I have one more poll question for you here. Let's do another poll. I just want to know what your role is. I want to see who we have on the call today and what your role is, if any. I only give you 3 options, so choose which one best describes you? Are you a designer? So are you an engineer and you're designing the pipe? Are you inspecting the pipe? Or are you an installer? Are you one of the people who works on the crew that installs that pipe? So I was just wondering who we have today. Okay, it looks like a majority of you are saying that you're the designer. So you're the project engineer and designer. A couple of installers, it looks like, but mostly designer. 78% say designer, 18% do inspection. So you're the inspector on the pipe, and 4% installers. Well, the good news is I've got something for everybody today. So hopefully everyone can take something from this presentation. That is my hope. But thank you for sharing those. Let's move on to the next. So because most of you are designers and engineers, I know how excited you get for good specifications. So we're going to talk what specifications apply to reinforced concrete pipe. If you remember a few weeks ago, we already talked about the ASTM C76 specification. This was our manufacturing specification that tells us what our wall thicknesses need to be, what strength of concrete we need to use, how much reinforcing steel we need to put into the pipe. So that's our manufacturing specification. That's what we take into account when we're building and manufacturing these pipes. We also talked about testing a couple of weeks ago. If you remember our 3-edge bearing test and our deload test to determine the classes of pipe. So we talked about ASTM C497, which is that testing specification. All right, today we're going to be talking about ASTM C1479, which is the installation specification. This is the national specification that gives the recommendations on how we should properly install these pipes. So that's what we're going to be discussing today. Okay, so high level, we're going to talk 2 different types of pipe installation. All right, the first one is the most common one that we see around here. Okay, this is our trench installation. A trench installation is one where the ground is built, we dig our hole, our trench, and then we put the pipe inside there. A couple of characteristics and defining things that you should know about trench installation, in addition to it being so common, is that there are some distinct design benefits to installing with a trench as opposed to the other type, okay, that we'll get to in a moment. Now, with a trench installation, you have the sidewalls where there's a certain level of friction forces that are going to provide some support for that load on top. And as we put our backfill material in, it's going to bind and hold that in place. And so it's actually a little bit better design situation to use a trench installation. Okay, so keep that in mind, that when we're looking at what type of pipe to install and we're trying to determine which class to use, we have to determine, are we using trench installation or are we using the second type of installation, which is this is a picture of it. This is embankment installation. Okay, now an embankment installation is very different from a trench installation in that the pipe, as you can see from this picture here, the pipe is sitting on the ground, and then we're going to build up our road all around it. Okay, or whatever it is that's going under there, whether we've got a dam structure or something on top of that. But we start at the very bottom level. We put our bedding in, we put our pipe on that, and then we're going to build up around that pipe. This installation method, admittedly, is not as popular here. We don't see it as often. You'll see it every now and then, so it's good to know about it so that you can remember the differences and remember that as we're determining class of pipe, we need to know, are we doing a trench or are we doing embankment? Because it could change which class you need to put in. So trench, we dig the hole, we put the pipe in, we backfill. It's got the benefits of the friction of the sidewalls of our trench that are going to help and not have as much load on that pipe. Embankment means that we're building it up around the pipe, and it is going to have basically the full load of that material on top of it and the loading on top of it. Okay. So those are the differences, trench and embankment. Just a quick review also about the classes of pipe. This is the table that we went over a couple of weeks ago, where we looked at the 5 different classes of pipe and what their loading requirements are. So class 1 is our lowest class of pipe. That is a lower weight that it can handle. It means it has less steel in it. And then you go all the way up to a class 5 pipe, which is our strongest, most sturdy pipe that has more steel in it than the others. It's able to withstand a larger load. And then if necessary, just keep in mind that if you get into these fill height charts and you get into an extreme situation where you're going to have very heavy loads, whether from really shallow cover and heavy loads or really, really deep loads. If you have really deep loads on there, maybe you'll exceed that 3,000. We can do special design. We can increase the steel. We can increase the mix design so that we have a stronger concrete. So there are things that we can do to make it bigger than a Class 5 pipe. In our market, the three most common pipes are your Class 3, your Class 4, and your Class 5. We don't typically carry Class 1 and Class 2 in the smaller diameters. If we get into a situation where there's a big price advantage from going to a Class 2 and all we need is a Class 2 at a larger diameter, you might see some of those. But for the most part, we're using mostly Class 3, Class 4, and Class 5 pipes in our designs here. So if you want to go onto our website and download our fill height charts, this is another option for you here on how we can determine what classes of pipe. And as we get into installation here in just a moment, I'm going to use some of the diagrams from those fill height charts down at the bottom of our homepage there at mountainstates.concrete.pipe. mountainstates.concretepipe.org. Excuse me, I misspoke there. If you go to our website and scroll down to the very bottom, you're going to see our fill height charts there. You can download them for either circular or elliptical. And so we're going to be looking at the circular fill height charts today. We're going to be looking at some of the tables from there. We're not going to be going into the level of detail of selecting classes, but we are going to look at the trench details and the soil classifications for those. So feel free to download those if you're interested. And let's get moving on our trench detail. There are some terms that I want to make sure we are aware of before we move on, because when we start looking and comparing and contrasting, I want to make sure that we understand what we're looking at here in this trench detail. So first of all, the first thing I want to point out is that this is that ASTM spec, ASTM C1479. So what we're going to be looking at, some of the tables that I'll be sharing with you are pulled directly from that specification. And if you go in and if you're using, I know the UDOT spec, for example, references ASTM C1479, and the APWA spec, which I know a lot of our municipal friends use that specification. It also references ASTM C1479. So a lot of what we're doing as manufacturers and recommending and the training that we give to contractors and to design engineers, we are basing that off of the ASTM C1479 because all of the specs around here also reference that specification. So a couple of things I do want to point out about this trench detail, well, I guess it is a trench, but it's also an embankment detail. If you notice on the left-hand side, what they've done is they've shown this detail. They're comparing the two between the trench on the left and the embankment on the right. Okay, all of the fill height charts that you look at when we get in and you're downloading them and you're reviewing them, all of them are for embankment condition. And if you remember what I said about embankment versus trench, embankment is going to give you a more conservative design. Okay, so if you use embankment, it might tell you that you need a Class 4 pipe, when if you run it for a trench installation, you might only need a Class 3. So if you want to go back and watch that first presentation we did where we went into pipe pack and some other options that you can do your own design to determine what class you need, you can do that. But remember that embankment's going to be a little bit more conservative. So they're going to show you what it is on the trench on the left-hand side versus an embankment condition on the right-hand side. Okay, next up. Okay, the spring line. This is a term that we have to, I want to make sure we understand, because the spring line, this is the middle line of the pipe, okay, right in the middle. So if your pipe is flowing at 50% full, right at 50% capacity, that line right through the middle of the pipe, that is our spring line. It is important that we remember that term, spring line, because in a concrete pipe system, okay, the critical pipe zone for this pipe is the pipe itself and everything up to spring line. That is the pipe zone. Okay, so it is important that we do a good solid installation up to spring line, and then we can do our typical trench backfill after that. All right, so that's the important part. When we design these pipes, we are designing them, this pipe system is designed from bedding up to spring line, and then the pipe itself. So that is the pipe zone. So that's very important. I know I keep hitting it over and over, and I'm going to touch on it again and again during this presentation, but I hope you can, I hope you take that away today. All right, so spring line, we've got that one. Next is our bedding. Bedding is extremely important, okay? Bedding is that area underneath the pipe, directly at the bottom of our trench, underneath the pipe, and it's important because this bedding is what receives the pipe. We said that a concrete pipe is a structure bedded with soil, so we're bedding that down into this soil, okay? Underneath that pipe or underneath the bedding is what we call the outer bedding, okay? So we've got our bedding, which is at that area between the bottom of our trench and our pipe. So that bedding, and then we've got our outer bedding. So keep that in mind. All right. When we're talking about bedding, I want to point this out. The recommendation that we give is that the middle bedding should be loosely placed or uncompacted. Okay. So that middle third there of that, we want you to leave that loosely placed. We don't want you compacting it. Okay, it doesn't do us any good to have 100% compaction on that bedding right there. And the reason is we need that pipe to be received, and it's going to cradle that in there, and it creates a nice little cradle in there. Where we're talking this bedding is, 3 or 4 inches is all. Even if we don't compact it, we're not going to change our grade dramatically enough for this to be an issue. So most contractors may put a little bit more there so that when it beds it, and it cradles that pipe, it's back on grade. But it's important that we do that because when we get to digging bell holes and other things, and if our pipe is slightly off grade and we need to home it or move it in a little bit, that if it's 100% compaction, something's going to give. And unfortunately, more often than not, if we start pushing on that pipe, it's going to put additional stress on that pipe, and we might see cracking at top and bottom. So we don't want to do that. So that's why we recommend that we place it loosely at the bottom there. Okay. Moving on, we have our haunch area now. So our haunches is going to be any of that area, that material between the bedding and our spring line. Okay, so that haunch, it's very important that we get that material compacted and shoveled in there underneath the haunches there. We want to make sure that we've got good support under there because this is part of that pipe zone, part of that critical area of the concrete pipe system. So the bedding and the haunches are really important that we get those installed correctly. Okay. Next to the haunches, we now have what's called the lower side. Now, if you look on the left-hand side of this trench detail here, our lower side is already in the trench, so there's not much we can do to fix that or to install that. Now, if we have bad material, we may want to widen our trench and over excavate and bring us more into an embankment situation if we're running into issues with soil. But for the most part, most soils are going to be able to withhold this and be okay. All right. If we're doing that embankment condition, it's very important that we take into account the lower side there. So I just want to make sure we have the correct terminology when we start looking at other things here. All right, over the top of that, once we get up to spring line, then we put in what's called our overfill or our trench backfill. Now we are running this strictly off of whatever our trench backfill detail is, okay? We don't have to go over the pipe with our pipe zone material, okay, our structural backfill there. We're just using our trench backfill material now once we get to spring line. Okay, so those are the terms. So let's look at this table from our fill height charts. I know this is overwhelming and it's a lot of information here. So we're going to take them one at a time. We already looked at table 3 down at the bottom, which are the reinforced pipe classes and the loads necessary for our 100th inch crack. So we're going to just ignore those. We're going to move on immediately. We're going to work backwards here, and we're going to go to table 2. This is our soil table. Okay, this has all of our different categories of soil. So we have our category 1, category 2, and category 3. Okay, our category 1 soils are going to be those gravelly sands, those AASHTO A1, A3 soils. All right, and it also gives your percent compaction, your proctors there. So keep those in mind It also gives you a summary of your USCS soil type so that you can determine, depending on what method you're using to determine your soils there. Our category 2 are going to be those sandy silts, okay, your A2, your A4 soils, all right? So they're a little bit more sandy, not as much, and more silt in there and not as much gravel, all right? And then your category 3 soil, that's going to be your clay, your much more fines. Those are your A5, A6 soils, okay? And below that, where we start getting into our A7 ASTO soils, these are not allowed for haunch or bedding. These are not great, even in any installation type. We don't want to use these extremely clayey soils for that. We want to eliminate as much of that expansive soil as possible, and so those are not allowed. But we've got our category 1, our category 2, and our category 3 soils. So when we look at our next table, table 1, now we can look at the different types of installation. So there are 4 different types of installation. Your type 1 installation is going to be that really, really strong, stout installation, okay? And the interesting thing about that is, yes, we might be spending more time and money on the installation type, but when we have a really good bedding and good haunch support, then we typically can look at maybe using a lower class of pipe. So maybe if you needed a class 4 in a type 2 or type 3, maybe if we go to a type 1 installation, you can save some money on using a class 3 pipe, okay? So that's one thing to consider when you're looking at these fill height charts and you're comparing types of installation. So your type 1 is going to be that really strong material. You're going to have that 95% compaction of category 1, that really good category 1 soil in your outer bedding. Remember, that's the area below your bedding, and your haunch, which is that area between your bedding and your spring line. Okay, your bedding thickness, it gives you, if you're using the D/24 material, not less than 3 inches. So you can go to 3 inches there. If you're using D/12, so a little bit bigger material, not less than 6 inches. So if you have that smaller material there, you would want to have about 3 inches of bedding. Remember, that middle is loosely placed, not compacted there. Type 2 and type 3, the bedding material is all the same on all of those. So your bedding thickness is going to be the same, but where we start changing is in our haunch and our outer bedding, what types of material we have and what types of compaction you need and how much compaction. So if you notice our type 2, if we're using that really good A1, A3 soil, that category 1 soil, we can drop it to a 90% compaction there and still be fine, still meet all of our design needs there. If we're using that lower material, that A2, A4 material, that ASTO material, we have to go up to a 95% compaction in the haunch and the outer bedding. So keep that in mind. The lower the type 1 is that really good, strong type of installation. Type 4 is going to be basically we're just pushing back, our native material back in and really not compacting anything. So keep that in mind there. Okay. So this is all, like I say, all found in those fill height charts, but this is the material and these are the information that we need to make sure that we're speccing out the correct installation, okay, for those. So I just wanted to take a brief break here and show you some unique concrete pipe installations that I've seen as I've been traveling around. And so the first one that I've always been impressed with is I want to give a shout out to the Ogden City Public Works building. If you notice, they use, instead of having just steel columns and pillars, all of the columns that they use in this building are actually reinforced concrete pipe stacked on top of each other. So I always thought this was a really cool way to showcase concrete pipe, and so we want to give a shout out to them on finding a really unique way to use concrete pipe. Here's the inside of the building, if you notice, and another shot of the inside of the building of those pipes stacked on top of each other. Another one, I was giving a lunch and learn a couple of months ago, back in February with Focus Engineering, and this is what I saw. So I want to give a shout out to them. These are a couple of concrete pipes that they use to hold up their desk. I'm assuming that's an extremely heavy desk if they needed those 2 concrete pipes there to hold it up. But anyways, yeah, so a couple of unique installations. Just wanted to share those with you. I found those kind of cool and unique there. Okay. When we talk about trench widths, this is an interesting point here. I want to give you an example of it. Let's take a 24-inch pipe, okay? Now, The ASTM spec, if you're using ASTM, they say that you should use a 40-inch trench for concrete. Now I look at that and I think to myself, okay, a 24-inch pipe, B-wall, which is common here in Utah. We learned a few weeks ago that if you take a B-wall, you take the diameter of the pipe, you add an inch for the wall thickness. So diameter in feet would be 2 plus 1 is 3, so the wall thickness is 3. So our total outside diameter of a 24-inch concrete pipe would be 30 inches. So I look at this 40-inch trench and I think, wow, that means that per the ASTM national spec, we need to have a 40-inch trench, and I think 5 inches on either side of that pipe. Is that going to be enough for me to get that compaction that I need? If I have to do a type 1 installation, am I really going to be able to get a 95% compaction in those haunches with only 5 inches between the trench wall and the side of my pipe? That's a real tough call there. I'm not a specialist. I don't do construction all that much, so I don't know if I could do that. Or who knows? But that's a great question on whether that's wide enough. Just for reference, if you're using a plastic pipe at 24-inch, the recommendation is 47-inch. Still, it adds about 3.5 inches on either side, but you're still under 12 inches, which I know a lot of compactors are about 12 inches wide. So my recommendation is when you're putting these trench details together as designers and you're telling them how to build these pipes and how to install them, we have to have a trench that's going to be wide enough for compaction. So please keep that in mind, that if we're just referencing the national specs, they're not always the best for constructability. So keep that in mind. All right, next up, we're going to talk joints real quick, okay? 2 different joint types. The spec is ASTM C990, but the 2 different joint types we're going to talk is tongue and groove. All right, if you notice, the characteristic of this is it's an inline joint, so it's the pipe when they come together are flat. We see these very often in our market with box culvert or elliptical pipe. We don't really see these very often in our smaller diameter circular pipes. So keep that in mind. Tongue and groove is mostly for our box culverts, our elliptical pipe. Our more common one is that bell and spigot. So we've got that bell that flares out and goes in, so it goes over. We've got a little bit more concrete thickness there at the bell so that it can provide additional support, and it's less likely to break there. So that's the more common one, especially at the smaller diameters here locally. All right. We had some great questions on some calls yesterday with some engineers about joints and about gaskets and some things. So I wanted to share that with you just so that we can get an overview of what the different types of rubber gaskets are that we're using in these joints. So this is going to be mostly discussing the bell and spigot joint here and the types of joints or the types of gaskets that we use on these single offset joints here. Okay. So the 3 types that you would see would be your O-ring gasket, okay? You've got your profile gasket, and then you've also got your self-lubricating or pre-lubricated gasket, okay? The specifications, and I'm going to go into detail on all 3 of those, so I'll come right back to that, but the specifications are ASTM C361 and C443. And the purpose of these, the hope is that if they're installed correctly, these are rated to 13 PSI. So you can have a little bit of head on your pipe, but that's what these are rated at, and that's what we designed these for, is to hit 13 PSI. So if your storm drain system is backing up a little bit, it should be able to handle those. You're definitely not going to be able to use these in an extremely high pressure situation, but in those lower heads of storm drain backing up, you should be fine with that 13 PSI. So first one we're going to talk about here is that O-ring gasket. This is the round gasket, all right? It's the circular. It fits inside this little notch in the spigot there. We lubricate the gasket. We lubricate the spigot. We lubricate the bell. We want to have as much lubrication as possible here, because as we home this pipe and we're pushing the spigot end into the bell end, this pipe is going to spin inside this little notch. And if we don't have enough lubrication, it's not going to spin. And the way that it compresses inside the bell and creates that seal all the way around it is by spinning as that bell goes in. If there's not enough lubrication, the edge of the bell can grab it and push it out so that we have, so that it's not in place and we're not going to get that seal. Other things it can do is if it's not able to spin in that notch, it can grab and it can pop your bell. So you could see cracking or issues with our bell or our spigot inside the pipe there. One thing you also want to do with all of these gaskets is what's called equalize the gasket, which means you'll run like a screwdriver or something around once the gasket's on, we want to run it around the pipe a couple of times in between the gasket and the pipe to make sure that you don't have too much rubber material at the top or the bottom of the pipe, because that would cause too much material, would cause that bell to pop off potentially. So we want to make sure we're equalizing that. Okay. The second type that we talked that I told you was the profile gasket. Again, this is one where you put this on the pipe. You would lubricate this gasket. Once it's on there, you would lubricate the spigot and gasket, and you would lubricate the bell. And then as you home this gasket in, this gasket folds over on itself between the spigot and the bell, and it's got enough mass in there that it creates that seal in between the spigot and the bell there. So you can see in the first one, we've got our joint there. We're pushing that spigot in, and so you can see it starts to compress. And in the third one, as we home that pipe, we get that compressed gasket so that it works just really nice, and we've got our 13 psi there. So this is the third one that I mentioned I would talk about. This is the self-lubricating or pre-lubricated gasket. This one goes on just like it does the profile gasket. We want to make sure that it's facing the correct way, both the profile and the self-lubricating gasket. If they're facing correctly, this one would have the lubrication chamber there at the edge of the spigot there. So we put that on. No need to lubricate this. As I mentioned before, this is a self-lubricating or pre-lubricated gasket. So there's no need to lubricate. What we've seen issues in the past where a contractor had lubrication from another project, took a pre-lubricated gasket, lubricated it up really good. It never got its seal. As they were homing and kind of pulling it in and out, trying to get it homed, the gasket slid off, and we had issues where the gasket was hanging on the inside of the pipe when we went in and videoed the lines after the fact. So you don't want to lubricate these. You want to get that seal on the spigot. And as you home that pipe and you're bringing it in, the spigot into the bell, it's going to fold over, and those teeth in that lubrication chamber there are going to grab one another and lock it into place so that we can have our seal. So you can see in the picture in the left-hand corner, that's as we put where we put our gasket. As we start homing it in the second one, the third one they've locked into place. This is what it looks like if you were to cut it in half. That's what that lubrication chamber looks like, and those little teeth, those little rubber teeth that will grab and bind and connect so that it won't shift and move. Okay. So that is rubber gaskets. So the three different types that you'll see. These self-lubricating gaskets are being more and more common. We're seeing those more in our market, where our manufacturers are using those more often. So you should familiarize yourself with them. Had a great question yesterday about self-lubricating gaskets. So it was good. We just wanted to point that out there. Okay. Next up, this is kind of a do and don't here. We do want to support these pipes on the barrel, because as we design them, the circumferential steel that goes around the barrel, that is our load-bearing steel. The longitudinal steel is just for support, to hold that circumferential steel in place. So these are designed to be supported on the barrel. So it's very important that we dig bell holes, and we go in and just dig these little holes so that the pipe itself can sit on the barrel. It takes just a few seconds to dig those bell holes. All right, and the reason is, if we were to come in and load this pipe, all right, if we were to have these pipes sitting on the bells, right, and we start loading them and we put a load on top, these pipes are going to want to deflect. All right, now we know it's a rigid material and they don't really deflect. So what's going to happen is, instead of deflecting, we're going to start seeing these little cracks that occur right in the middle of the pipe, right? So we're going to have these circumferential cracks there. It's interesting when I look at videos and I can see every single pipe that has a crack right in the middle of the pipe, a circumferential crack. It's pretty clear that somebody didn't dig bell holes. And so we want to make sure that we're digging those bell holes and we're taking care of those. Okay, now we're going to have a quick little break here while I wanted to show you a video. I'm going to see if this works. We're going to try it out here. This is a video of Randy inspecting a pipe. Okay, so we're going to see if this works here for us. So this is an old video I found of Randy doing a pipe inspection. when he was younger, a lot younger. So I'm just going to show. So this is a young Randy inspecting concrete pipe. Anyway, so there you have it. Okay, so just wanted to share that with you so you could see Randy doing his thing. When we're homing these pipes, if we're going to use a pry bar to home it, we want to make sure we provide some wood in between so that we're not damaging the pipe itself. We also had some questions yesterday about joint gaps, so I wanted to talk joint gaps. Every pipe is different. Every pipe manufacturer is different. Every diameter of pipe can be different. So this was for a project that was done down in the Las Vegas area years ago. This is a table that I pulled from some specifications, but this gives you an idea that depending on different pipe sizes, you might be able to have different gap tolerances. Okay, so you don't always have to have the pipe completely homed for us to be able to get that 13 psi. That's really what our goal is. We want to make sure that we're doing it. So these joints are designed to be able to handle a little bit of a gap. Okay. Once we get the pipe homed and in place, then we start bringing the backfill. So if you notice in this picture, this is a trench that when they installed this, they used a 56-inch trench on a 24-inch pipe. So they should have adequate room to take their shovels and use those to compact and shovel in and knife in underneath those haunches and get that material underneath the pipe there. Okay, another here, if you notice, they do have enough room there for the compactor to compact against that in between the trench wall and the pipe wall. So we want to make sure that we've got enough space there. They're doing a couple of lifts here, putting in another load of soil on top of that there, our backfill and our good material so that we can compact. And then in this picture I show, because this is, now they're up to spring line and we're done. This is our critical area there of that pipe. So we put that up to spring line, and then we can just put our trench backfill material in after that. Okay, I just wanted to share a few practices that you should avoid. All right, number one, you should avoid homing the pipe with the excavator bucket if you can avoid it there. I mean, that is, if you come in and smash the pipe with that excavator bucket, you can cause damage to the pipe. So we want to find either using pipe pullers or a pry bar, and maybe putting wood in front of it to cushion against it, but we want to avoid that if we can. Another one is regrading the bedding when the pipe is homed. So if we home that pipe in and then we realize, oh no, we're an inch too high, we're off grade, we need to pull that pipe back out, regrade it, and then put it back in. If we were to just lift that pipe up and start grading underneath it, we could pop a bell or a spigot and cause some damage there. Okay, another one is to using our excavator bucket to put the pipe on grade. If we're a little bit short, we don't want to just smash it with the excavator bucket. If we're going to lightly push it down in a little bit, we can use some type of wood or something on top, put a 4x4 on top of it, and that way you've got that little bit of cushion between the metal and the concrete pipe there, the metal of the bucket and the concrete pipe. We don't want it smashing in there and causing unnecessary damage there. And the other one would be that improper joint lubrication, whether we're putting inadequate amounts of lubrication on joints that require it, like our O-ring or our profiled gaskets, or if we're using lubrication on a self-lubricating gasket that doesn't need the lubrication there. That could be problematic as well. Okay, so I have a question for everybody, and I want you to consider this. This is a frequently asked question that we get from a contractor. He comes to you as the design engineer and he says, hey, can I substitute flexible pipe, either plastic or corrugated metal, for RCP on my project? All right, this is a very common question. So I'm going to put it to you. We're going to put it out to everybody here. Can you substitute flexible pipe for RCP in a project? Go ahead and answer this question. The answers are yes, no, I don't know, or it depends. All right, can you substitute flexible pipe for RCP on your project? Okay, looks like, I'll give you another couple of seconds here. Okay, so handful of you said yes. Handful of you were honest and said, I don't know. 15% of you say no, and 72% say it depends. Okay, the correct answer is it depends. Okay, here's what we've been getting this a lot lately, and this is why I bring this up. Okay, we've been having a lot of questions from engineers about pipe availability. We are still manufacturing pipe. We're running full crews to keep up with the demand, and so even with the COVID-19 things going on, we are still considered an essential business for the construction industry. So we are manufacturing pipe. We have been getting questions and saying, you know, we're told that your pipe is out 12 weeks or 15 weeks or whatever. Can we substitute for another material, whether it's plastic or corrugated metal? Okay, they've been calling us and saying, is it true that you're out this far? And so we've been able to answer those questions and say, in most cases, no, we are not out that far. So for specialty cases, it could be a little bit longer, but for the most part, we're in the matter of weeks, 4 to 6 weeks typically. But you'll have to reach out to each individual manufacturer. So the answer is, if a project is designed for concrete pipe, that is designed for RCP, flexible pipe is not an equal substitute. So keep that in mind. It's not just an equal substitute. You can't just say, all right, we're going to flip it over. You have to update the design. It must be updated if a contractor changes to flexible pipe. This is for those projects that have specific details and trench details and specifications for concrete pipe. You cannot substitute it over without having long-term repercussions for the pipe and the installation. Okay, I'm just going to do a quick comparison table here, and we're gonna just show a few differences, because we have to understand that these materials are different. So we're going to have a rigid column and we're going to have a flexible column, and I'm going to show you the differences between the two just at a very high level. Okay, and just so that you can understand why we can't substitute these over. Okay, so the first one is rigid pipe. We mentioned at the very beginning of this presentation, rigid pipe is a structure that is bedded with soil. Okay, flexible pipe is a liner that requires the soil around it to become the structure. You have to compact that soil to build the structure. So where every pipe system has to be both conduit and structure, right? Concrete pipe is the structure that we're delivering to the site. Flexible pipe is a liner that requires you to design and install the structure in the field. Okay, the pipe zone is different. I've hit this a lot in this presentation, that the critical pipe zone for a reinforced concrete pipe is up to spring line. Okay, from the bedding to the spring line is our pipe zone. Above the spring line, you can backfill with your typical trench backfill. For flexible pipe, it is 12 inches, typically 12 inches above the pipe. Depending on the loads and different things, it could be more than that, but typically it's a minimum of 12 inches above the pipe. So where you can stop your compaction and backfill at the spring line for concrete pipe, and then use your just typical trench backfill material and compaction requirements, flexible pipe requires this to go 12 inches above the pipe, so a significantly more amount of structural backfill and compaction. Okay, the lift thicknesses for concrete pipe, it is not specified in the specifications. In ASTM 1479, it does not give a specification on the lift thicknesses, only what the compaction should be. So if you can get to those compaction numbers, the contractor can determine how many lifts he needs to do. Okay, the flexible pipe is different. The specifications, ASTM D2321, and the manufacturer's recommendations for most of these pipe materials is 4 to 6 inches of uncompacted lifts. So for a 24-inch pipe, you could see anywhere from 7 to 10 lifts on these pipes. So significantly more lifts that you need to do, because remember, we have to build that structure in the field. All right, so the structure, let's move on to that. We are manufacturing that in the plant, quality controlling it, and shipping it to your job site. Okay, with flexible pipe, the structure is built in the field. All right, the design is handled by the manufacturer. We are designing that according to ASTM specs or doing direct design for those pipes that require more load than the ASTM specs allow. And so we are designing that, and we are taking care of the structural side of things. For flexible pipe, the project engineer is the one that has to do the design on that flexible pipe there, okay? So I'll close with this slide here just so that you can see. If we have a flexible pipe and we load that flexible pipe, it's going to want to deflect outward. So it is very, very important and critical that we have very strong, good, stiff material on the sides of that pipe. And that's why we need to build in 4 to 6 inches of uncompacted lifts to 12 inches above the pipe. Okay? With a rigid pipe, if the pipe itself is rigid and stiff, it's not going to go anywhere. So we are allowed to have a little bit more flexible soil and material on the sides of that pipe. So those are the key fundamental critical differences between the two, and why we cannot substitute straight across the board a flexible pipe for concrete pipe. So for those of you that answered it depends, you were correct. That is absolutely correct there. All right. The takeaways were installation types. We discussed those. We talked about the best practices for RCP, and we did a pipe material comparison. Quickly before I get to questions, I have one more poll here that I want to do. This was Randy wanted me to ask you guys this. Okay, we're going to ask you how many of you did your taxes by April 15th? Most of you, well done. Congratulations. Way to go. Randy, it looks like we've got some really good people. However, for those of you that are with me in the 42%, I believe we have until June. So way to go. Let's procrastinators unite. And maybe tomorrow. Okay. Thank you so much for that. This is my contact information. I'm going to take a few minutes now and address some of the questions that we had. So thank you, those of you who sent in questions. I'm going to open this up and start going through these questions here. And I'm going to have, if Randy, Heather, and Mike want to chime in and help me answer these questions, we can go ahead and do that as well. All right. Will Mountain States be paying for counseling sessions to remove Jason's uniform outfit from our memory? Mike Kendall. Thank you for the question. You would have to direct that directly to Randy, Heather, and Mike. You could, I would say, submit your invoice for your counseling, and you know, the worst they can do is say no. Okay.
Actually, we were chatting about this as panelists.
Okay.
And we decided if people wanted to submit suggestions for his next outfit, we'd be willing to purchase it and suggest that he wear it. We don't think it would take much of a suggestion, though.
It would have to be PG rated. I mean, I'll let you go PG-13 even, but be smart. If you want to do that, feel free to log on to our Facebook, post a picture from a set of jammies from Amazon that you would like me to wear in a coming presentation, and I'd be happy to do that. So yeah,
I think
I like that.
We had looked at a big and tall store.
Okay. Okay.
For women.
Of course, naturally.
I found a really nice flying squirrel pair of onesie pajamas on pajamasbuy.com. So I'll recommend that one on your
Oh,
Facebook.
Heather, don't you toy with me. You know I've been wanting a flying squirrel pair of jammies.
It's a good one.
All righty.
Actually,
Cecil says,
actually,
hey, you
I
added my
already
response.
did that
Yes, I did,
statement.
Cecil. I added the response of no, I don't wear pajamas at all. So you're welcome, Cecil. I did take your recommendations from last week and do that. Okay. So what is a suitable width for compaction? 12 inches. BJ Miller, great question. I would say it depends. Most contractors, I believe, can get that compaction with 12 inches. That would be my recommendation for a minimum. Okay, now keep in mind as well, if you go a lot wider, you're going to lose some of the benefits of that trench compaction because it's not right up against the sidewall anymore and you're losing that friction. So if you go too wide with a trench and you over excavate too much, you might lose some of the benefits of that trench and you might have to design it for an embankment condition. But I would say for the most part, we recommend that 12 inches is on either side of the pipe, not 12 inches total, but 12 inches on either side would be suitable for compaction. All right. What type of gasket should we expect to get from Oldcastle and Geneva? So, Oldcastle, I'll let you guys go. What gaskets are you using? I'll let you go first, and then we'll ask Heather and Mike from Geneva's standpoint.
Oh, am I going first?
Yeah, go ahead, Randy.
Um, Mostly I think we're using self-lubricating gaskets now.
Okay.
We'll get into some regular profile gaskets still, but then when we get to larger size, larger diameter pipe, I think we've still got a few O-ring gaskets, but that's above 54 inches.
So larger diameter, you might see an O-ring, but mostly you're going to see self-lubricating for your smaller diameters and occasionally profile. Wonderful. Heather and Mike.
Yeah, so for Geneva, we have a mixture of all three. It depends on the pipe size.
Okay.
So we'll do self-lubricated gaskets. We'll have profile gaskets, and O-ring gaskets are specific to our microtunneling pipe.
Oh, okay. So if even your larger diameter, you would either be the self-lubricating or profile, but if you're micro-tunneling, then you would see the O-ring. Perfect. Thank you for that. Excellent. So someone commented that the video was cool, Randy. Thank you for providing that for me. I hope to be able to inspect videos or inspect pipes like that in the future as well. Let's see here. I hope Randy isn't asking who did their taxes in order to find someone who might volunteer to do his taxes. Is that why you wanted to know, Randy?
I actually didn't know they were due in June now. I thought it was just indefinite.
Oh, BJ, I believe you're right. I believe it is July 15th to do taxes, not June. But I don't know. My accountant said he would have them done by the end of this month, so I don't care. I'll have mine done. Okay, Dexter asks, great question here, Dexter. I love this question. Is crushed rock an acceptable material for bedding and pipe zone? We're going to just focus on concrete pipe on this one because we didn't talk too much about bedding and pipe for flexible pipe. That's a lot. That's a whole different story there. But crushed rock, crushed sewer rock for bedding and pipe zone material. Randy, you want to field that one?
You know, we like crushed rock. When it gets down to pea gravel, you got to be a little more careful because it can flow and you got soils migration. So you got to really look at it. But, you know, it really depends on the application. But a lot of contractors like crushed rock. And for the most part, it works out fine with concrete pipe.
Okay. Perfect. I think what you're looking for with the rock, as Randy mentioned, pea gravel is typically rounded, uniformly graded. It flows quite a bit. With the crushed, the reason the crushed gravel is better is because you're able to lock into place and hold it. It's able to lock in, so it's not going to go anywhere as easily as just a typical pea gravel. So yeah, keep that in mind. That crushed rock is typically you know, a well-graded material is good if you need to get those compaction numbers, but yeah, depending on your type of installation, that's the key. If you're not able to hit those compaction numbers with the different material types, you can always look at maybe a type 3 or type 4 installation if you need to. So great. Jeremy Lapp, the answer to your first question is yes, most definitely they do. Let's see. Oh, Jeff Erdman, great suggestion. He just suggested a Teenage Mutant Ninja Turtles PJs. Jeff, I don't know if we'd even have to buy those. I may just have a pair of Ninja Turtle jammies. We'll have to see. Jeremy has another question. What things should an inspector look for when pipe is delivered as grounds for rejection? Oh, great question, Jeremy. Great question. We're looking for any cracks that are larger than hairline that go through the pipe. We're looking for major chips in the bell and spigot area that might affect the ability for that gasket to create a seal there. Now keep in mind, even if they are delivered and there is a little bit of damage, and typically we're inspecting. I mean, we are inspecting every pipe as it gets loaded onto the truck. So in transit, if there's an issue, if something happens, or as they're unloading it. There are specifications that allow us, national specifications from AASHTO and other ASTM has one that allow some repairs to be done as well. So if they're not complete structural damage to the pipe and it's just maybe a functional or cosmetic, we can go in and repair some of those things as well. But that's typically what you should be looking for is chips that would large enough that would impact your gasket seal and large cracks that go all the way through the pipe. Those are some big concerns. Randy, Heather, feel free to chime in if there's any other things that these inspectors should be looking for to reject if they see something in the field there.
Well, I think you hit it pretty well, but sometimes they'll reject the pipe, and it may be that we have a joint that's damaged, and it could still be cut off and used in a short section that goes in a catch basin or something.
Yeah, good point. Great point. Great point. Heather, anything that I missed that you've seen out there with rejection or?
No, I think you did a really great job on answering that question. Okay.
Thank you. I just wanted that affirmation from you, Heather. I just love getting positive affirmation from you and Randy. Okay. This is a question from Matt. Does the UDOT spec require compaction tests of the bedding under the pipe before the pipe is placed? And doesn't this conflict with the recommendation of uncompacted bedding material under the pipe, or do they just test the haunch backfill? Oh, that is a great question. I'm trying to remember what the compaction requirements are for the UDOT spec. Randy, you may have to help me out on this because I may have to answer that one offline.
The compaction requirements on UDOT?
Yeah, do they require a compaction test on the bedding? I don't think that they have a compaction requirement on the bedding, that 3 inches of bedding material necessarily. It's just the haunches and then up in the trench backfill as well.
And you want to make sure not to compact the bedding right under the pipe. That's one thing, but I think there is a compaction requirement. I just don't know the testing frequency.
Okay.
Because it's UDOT spec goes more towards a road base, so it can be tested.
And BJ wants me to come into their office and show them some of the elements of a self-lubricating gasket. So I'd be happy to, BJ. I'll bring you a self-lubricating gasket and show you all of the elements and go through the different names of each one of the elements of that gasket. Jeff, this is a great question from Jeff Erdman. Why are some pipe joints painted white? That's a great question. So, Randy, I know you answer this pretty eloquently. I've heard you answer it before. Do you want to take this? I could answer it, but I'll let you. I've been talking enough.
I'm having a really hard time answering these. People keep texting me about potential outfits, and so far it's Princess Leia, but I'm not sure which version.
Oh man. I hope it's not the Slave at Jabba's Palace version. I don't know if anybody wants to see that.
Let me hurry and comment on that last question about UDOT compaction requirements.
Yes.
Kathy Colburn with UDOT is on the conference webinar. She says we do not require a compaction test on bedding underneath. They follow ASTM spec, but she can send her standard drawing. So
perfect.
So they don't.
Thank you so much, Kath. I appreciate that. That's a great answer to there. Okay. Excellent. Pipe joints, some are painted white. That is a great question, Jeff. Randy, you want to handle that? You want me to take it?
When there used to be an air test requirement in UDOT, Oldcastle used to paint the bells white because we could have actually air leak along the length of the barrel that wasn't a joint leak or water wouldn't leak, but it was difficult to air test. So we would paint the bells white to make it easier to test. Right now, there's very few jurisdictions that require an air test. So we don't, for the most part, we're not painting those white.
Okay, great question there. So that would be, I guess it's another way to know that they are air tested and they've been air tested. So great question there. Next one is, do manufacturers label the interior of the pipe? Yes, we have stencils that we put on, both companies have stencils that they put on the inside of the pipe. Typically those would have the manufacturer's name and I believe the class of pipe, and that it meets ASTM C76. Did I miss anything, Heather? That's what I'll right?
Generally we'll have the date that it was produced.
Oh, the date as well. Okay, thank you.
And I know ours is just on the exterior,
okay.
Unless I think the UDOT spec requires some markings on the interior, but on ours, the stencil that's typical is on the exterior.
Okay, so it would be on all the exterior of the pipe, and if spec requires, we would do a stencil on the interior. Okay, excellent. So probably not standard. I think that probably answers your question, Jeff. Probably not standard protocol, but if you require it where like UDOT it is required, that's where we would stencil the interior of the pipe. Great questions there. I think that was our last question. So thank you so much. Great questions today. Excellent. I will be, as I mentioned before, I will be downloading this. I'm going to create a YouTube page because I think that's going to be the easiest way to get these out to everybody. So if you ever want to go back and review any of these presentations, feel free. Remember, next week, keep an eye out. Anybody that was on the call this week, I've added you to our email list. I'll be sending out your PDH certificate either this afternoon or Monday morning. So keep an eye out for that. And I'll be sending out an invite next week, early next week, either Monday or Tuesday, to our millennial presentation that we'll be doing next Friday. So be sure to tune in to that. That's going to be a lot of fun. That's one of my favorite presentations. So thank you again, everybody. I appreciate it. This has been a blast today. I've had a great time. So if you have any specific questions, feel free to email me directly. Make sure you go in and submit your requests for my jammies as soon as possible so that we can get those ordered in time for next week if necessary. So thanks again, everybody. Thank you, panelists. Heather, Mike, Randy, I appreciate your help today. You guys were great. Have a great one, everybody, and have a very safe weekend. Thank you.
Thanks,
Thanks,
Jason.
Great job.